Welcome to Spreadsheets in the Math Classroom. You can access all the resources for this slideshow at bit.ly/spreadsheetmathk12. Have you ever heard a student say, when are we ever going to use this? So how can we leverage Google Sheets in the math classroom to engage students in more relevant, student-centered learning of math while integrating those essential spreadsheet skills more deeply and engaging students in an inquiry approach to learning math? And it can be as simple as columns and rows. Oh my. All right, as we all know, there's all different types of skills that are currently needed in the workplace, and the top skills that the Economist Group has researched, and you can click on this image to get to that research if you'd like to see it a little bit different in more detail, is obviously problem solving, teamwork, those 4 C's idea of critical thinking, creativity, communication, collaboration, all those types of things, but also digital literacy too. So a lot of the skills that are required can be tied back to spreadsheets and helping students work collaboratively on spreadsheets together in learning the math that they need to learn. And then we can ask ourselves, and drilling down from kind of like the employer's perspective down towards, okay, what makes a good math student? And we always kind of think about that 40-40-40 idea. And what do I want my students to learn after 40 minutes? What do I want them to remember after maybe 40 weeks, school year, if you will, and then, or even just 40 days. And then finally, 40 years from now. And that idea is wrapped up in the standards for mathematical practice from the Common Core State Standards of, making sense of problems, reasoning abstractly, constructing arguments, modeling, attending precision, using tools, making use of structure, and look for and reasoning and kind of patterning in math. And those standards for mathematical practice, you click on this graphic, will pop them up to if you'd like to read a little bit more deeply into them. And again, spreadsheets can really lend ourselves for those students to develop these skills. So the learning targets for this session is obviously leveraging spreadsheets in the math classroom to deepen that student understanding and also offer more relevance, as we spoke about, because really spreadsheets are just a way that algebra is used to display data in very usable format by others who maybe aren't so math savvy. And the idea too, besides the relevance piece, is the universal design for learning, having students gain access to math content different ways rather than just solving problems all the time and coming up with answers, leveraging tools like graphing calculators or spreadsheets or manipulatives. It's just a different way for students to connect to the content and learn the information they need to learn. We're going to also share a lot of ways that you can find student-centered inquiry-based experiences with math and spreadsheets. Obviously, understanding problem solving in the digital age is covered with using spreadsheets, and also the skills. Basically, the way this is going to be broken down then is starting at the primary grades with some examples and then moving down into the secondary and middle levels. But also during this, like for example, when we get into this one, you're going to learn just skills yourself, not necessarily you'd use this with your class, but you're going to learn a little bit about conditional formatting in this example here with the gummy bears. I have a lot of resources linked throughout. So for example, if you want some more background information about graphing with gummy bears, this takes you out to Christine Pinto's website, where she shows you how she used it with her kids, where the kids are using actual manipulatives and a spreadsheet of bridging that gap between the concrete, the representational, and then moving them into the more abstract piece too as well, the CRA of mathematics. But she gives a little bit of background on this. She is fantastic. Highly suggest you check her out if you do teach primary age students. If you click on Graphing with Gummy Bears, it'll actually make a copy of that spreadsheet so that you can play around with it and manipulate it yourself if you'd like to and dive into the formulas. And in this case, we'll be looking at some conditional formatting pieces. All right, so we're in the spreadsheet. I just have my menu minimized a little bit, so it's a little bit more space for me. Let me zoom out a little bit more. Control minus. All right, so this is where kids would come in and they can just put anything in here, an X, they could put a 1, an A, anything in there, any type of character that is actually put into one of these cells will actually color the cells because it's set up with conditional formatting, so I'll explain that next. So it's just a way for kids to get into counting. There's a formula to count how many things have something in it, if you'd like to dig down in that formula too as well. We'll be looking at if statements in a little bit too as well. So if I just highlight this first column here where we have the red bears, maximize the menu, go into format, and go to conditional formatting. That allows me to bring up the side pane that shows me the conditional formatting rules that have been applied to that cell or those range of cells, in this case B2 to B11. So from here to here. So if I click on this rule, it shows me apply to the range B2 to B11 if the cell is not empty. So that's how it changes the cell. If it's not empty, what I want you to do is change it into pink. Again, I could change this to green if I'd like to, or I can change it to pink. And what you notice there is the text color adjusted too when I switch that. So really, you can have that condition be set so that the same color of font and the same color of fill is exactly matching. So you make those numbers and letters disappear for the students. So in this case, if I come over here to the yellow column, format, conditional formatting, oops, you can see that I have these range of cells managed by these format rules. And now we have the font color change to yellow versus a fill color of yellow. And that's again why we do not see that letter there. Again, I can change this to a different color and then it'll pop up. So that's just a simple example of how you could start to have kids get more experiences with spreadsheets in the primary level grades. If you'd like to take a little deeper look, there's also a link here, exploring graphing with kindergarten students using Google Sheets. A lot of other templates there too. So activity 1 done. Now we're going to move into activity 2, more appropriate for those grades 3 to 5, those intermediate grades. I first want to kind of talk about fluency first. A lot of our kind of experience with math is like memorize your math facts, memorize your math facts. And really, memorization falls apart as students get older and into more abstract mathematics because you can't memorize everything. So what we like to do is not only be accurate and fast and efficient, but we also need to be flexible. Fluency with flexibility really builds a more foundational understanding of numbers and having number sense. And the NCTM president kind of goes through the idea of what fluency should be. And the idea, again, is not just memorization. Not that memorization is bad, but it shouldn't be the only way that students learn. I'm going to be getting up to just the facts example activity, but I do want to cover a couple more things here. So the first link here is the plus, minus, multiplication, division progressions. And this is just a spreadsheet to kind of show you the different strategies for addition, subtraction, multiplication, division that students should be exposed to. So for example, most students pick up their doubles pretty quickly. So 4 plus 4 is 8, 6 plus 6 is 12. They generally pick that stuff up pretty quickly. And then what we can do is leverage that strategy and say, okay, well, what if I see 6 plus 7? Oh, well, that's just 6 plus 6 plus 1. And then I know that's 13 because I'm 6 plus 6 is 12. Or 6 plus 8. Well, 6 plus 6 is 12 plus 2 more gives me to 14. So I remember growing up myself, I actually struggled with 6 plus 8, and I also struggled with 5 plus 8 because I couldn't memorize it. And if I knew these strategies, I would have been like, oh yeah, 6 plus 6 plus 2. No one really told me those. If you want kids to practice these too, we have a link out to FLIPPITY flashcards that allow them specifically to practice on that particular skill set. So these are the doubles skill set that I clicked on. If I do doubles plus 1, then that'll flip out to some flashcards that deal the doubles plus 1, and it kind of goes up here. You can randomize it if you'd like to. So there's 9 plus 9 plus 1, so it's 19, etc. There's different ways you can practice using these flashcards too as well. But that's just a nice resource. So if you drill down and working with a student and you know they're struggling with multiplication, a lot of times because they don't have that addition strategies. So you might want to go back and do kind of like a running records piece and try to make sure they know these and have been exposed to these before you go back and kind of focus in on multiplication too as well. So a nice resource there. The other resource that you can help students work on is, we mentioned those FLIPPITY flashcards. So we have created a repository, and my compadre, Dan Kaufman, who's our instructional tech coach here, our instructional math coach at Wilson School District, he's helped develop a lot of this with me. He's really done the yeoman's work. This is just a document that has all different types of flashcards for kids to practice their fluency in different skill sets. So for example, this one's looking at fraction area on a number line. So if kids are not really understanding what fractions are, they can really look at, okay, that's a half, and they can move on, and that's a fourth, and etc. So these are all just flashcards to work on that skill set and number fluency, if you will. All right, so enough about fluency. Let's actually get into an activity that students can do. And you can use this varying ways. I'm going to be talking about some formula stuff that might not be appropriate for your students. It might be appropriate for you, or maybe older students too as well. You notice across the bottom I have all these tabs open. One's an answer sheet, one's a blank sheet. This table of contents allows you to hop to any two as well. Also, I can hide a sheet. So if I didn't want these answers for a student, I could obviously delete this tab before I send it out to them, obviously making a copy first probably. But I can also hide that sheet, and then that goes away from the bottom. It can be located in this table of contents. You can kind of see it is faded out there. To bring it back, you just click on it too as well. So I'm just going to get into some simple spreadsheet skills with formulas, just so you gain some skills, but also remember we also want our students to gain some skills. So obviously if I'm going to make a addition facts table, I can just type straight across if I like to, or if I highlight everything and I grab this handlebar here where I get like a crosshair, I can drag across and Google Spreadsheets recognizes my pattern and then just automatically copies that over. So for example, if this was 2, not 41, but 4 and 6, it's recognizing that I'm counting by twos. So it actually will match that pattern too as well and count by twos. So we can quickly and easily fill in that top row for our addition facts. And I could do the same thing down the side, but I'm going to talk about formulas to do it a little bit differently. I could do the same thing I did up top, or I could do some referencing. So when I do an equals, it tells Google Sheets I'm actually do some calculations with a formula, and this is really where we start to attach the algebraic understanding so we can teach algebraic concepts to younger students using spreadsheets. Because now I can say, hey, take what's in A2, and Battleship is a really cool way for kids to learn about coordinates, and just add 1 to it. So take whatever's in A1 or A2 and add 1 to it. And then once I have that formula referencing A2 plus 1, I can again just grab that handle and drag down. And again, it's just going to do a relative reference. It's going to change that A2 to an A3, and that A3 to an A4, and the A4 to an A5. So as I copy down, it automatically changed that A2 to an A3 automatically. You can kind of see it highlighted in orange of what cell it's being referenced. So once you kind of have this built, now kids can come in and they could just do it by brute force. They could just say, all right, well, that's going to be equals 1 plus 1. And this one's going to be equals, to get into the formula, I'll just start with a column, I guess, 2 plus 1, since I'm going down. And this one I could do 3 plus 1. And I could brute force it. So that might be for a student who maybe has never really experienced a spreadsheet yet. But that's a lot of work. I got to do all these facts to do it that way. Not bad. Again, the kids can then kind of work on columns and rows and things like that. But I could get into formulas too. I could say, okay, take what's in A2 and add what's in B1. So I can reference those cells without the equal sign. If I just do 1 plus 1, it actually just going to put that text in there. But as soon as you put the equal sign in, 1 plus 1, it knows you're trying to do some calculations. So equals A2, and I can just type B2. I don't have to click on it. It's easier to click on it, but you can type B2. Oops. I meant B1, not B2. And now once I have that formula in, I see it's referencing A1 and A2 and B1. I can grab that handlebar and drag down. Uh-oh, what happened there? It didn't work, because what is happening is a relative cell reference. So you can see A2 plus B1 is the formula here. Let's grab this formula bar, make a little bit more space up there. But when it got copied down, look what happened. As you copy down, the A's are changing appropriately because we're moving down, so it's relatively moving the correct direction. But notice now we're referencing the cell above us rather than that B1 cell like we were supposed to. So what you can do is what they call an absolute reference rather than a relative reference that changes as you copy and paste. Hey, I want you to stick to that first row. I don't want the row to change as I copy down. So I can put a dollar sign in there. I'll zoom in for us too as well. And now once I put that dollar sign in there, it's telling Google Sheets not to change that value 1. So now when I grab that handlebar and drag down, look at this. So now it's sticking to the first row. I'm not moving over, so it's not going to change the B, but it's not changing that 1 every time it is referencing that top cell. So I have it built. Now I can drag across. Uh-oh, it didn't work again, because now let's look what happened. Okay, the C1 is changing correctly, D1 changed correctly, but notice now we're again referencing the cell next to us, because over here was A2. We want it to stay at A2, but now it changed to B2, and it changed to C2 and D2. So it's taking the number right next to it now. So we have to go back and fix our formula and say, hey, as I'm going across copying, I do not want to change my column. I always want to reference here. And since I'm going across, it won't change the row 2. So I can, again, add that $sign to tell Google, hey, I don't want to change the A as I copy across. So I have 2 cell references that are absolute there, and I drag across, and it appears to be working now. So you can see it is doing E1 here with A2 here, A2 with F1, A2 with G1, etc. And now since I've built this with 2 references that work no matter which way I copy, I can actually copy all the way down. And again, I can just make sure by randomly clicking on things too as well. The purpose of this might not be to help kids understand absolute references, and maybe you don't fully get them either, because it takes a little bit of brain power, a little bit of experience with spreadsheets to kind of fully understand how references work. But the bigger point here, I think, is like when you're looking at this as a student, maybe after you are pretty secure in your math facts, you ask kids, hey, what do you wonder? Or what do you notice about the numbers here in this addition facts table? And you're like, oh, look at all the diagonals. All right, well, why does that work? Why do the diagonals all equal each other when you go on a diagonal, kids? And they could explain, well, one value reduces, one's getting bigger, blah, blah, blah. And that's the thinking, that's the communication. As we communicate our understanding, our socializing our understanding, that's when we actually solidify it. Instead of just memorizing our facts, let's look at and see those patterns, getting back to those math practices. We can also leverage that conditional formatting thing that we talked about with the gummy bears. I'm just going to maximize the menu here, go to that format and go back to the conditional formatting. And right away it says if the cell is not empty, turn it to green or turn it to yellow or turn it to pink. So since the cells aren't empty, they're automatically being formatted. Move me over here. So what I can also do is next to in the conditional formatting's pane, there is a color scale piece. And the color scale piece is applying to the range that I had highlighted, B2 to K12. And now I can actually change the color scale to different colors too. Again, hitting that universal design for learning idea for students, because maybe someone's really into arts in your class or loves colors. Maybe this is a great way for them to see the numbers. So as they get darker in red, they come up in value too as well. So another maybe visual cue for students. Again, you can kind of check the answers if you're not sure about the formulas. You can kind of dig in a little bit in the answer tab there. We can similarly do the same thing with the subtraction facts. I'm just going to actually copy. Let me remove that formatting. Control Z is so nice to undo things. I'm going to copy that because all I have to do then is change it from subtraction. I don't have to go through all the building it here. Excuse me. And Google has this new thing with Google Sheets. It's saying, hey, do you want to autofill this? Sure, thank you. And again, I can just check to make sure that it's referencing the right values. And then once I build that, I can click on the first cell. I can drag down to highlight everything, but a little trick in Sheets too is I can go down to the bottom value, hold down Shift on my keyboard, and it'll select everything between, and then I can drag it across. And again, now look at all the patterns, kids. So again, after they're done and they're secure in their subtraction facts, maybe this is another opportunity for kids to notice and wonder about the subtraction facts table from 1 to 10. And again, you see some diagonals. Why are all the negatives over here versus the positives? How could we make that different? How could we have the negatives down here and the positives up here? And maybe they could get in and think, oh, well, what if you did, instead of A2 minus B1, maybe we switched around. Maybe if we took the row up top and subtracted by the column along the side. Let's see what that looks like. And I can copy that down now. And now automatically those negatives flipped on that zero axis, if you will. You know, why are these zeros, kids? Again, nice way for kids to kind of see that patterning. Again, here's some answers for facts. Multiplication. Oops. Grab the right formula. Multiplication is similar in nature. We just do the same thing. Autofill's fine. Thank you, Google. Highlight everything with Control Shift and down arrow. And now I have my multiplication table. Again, depending upon where your students are, you might want them to build this table just by brute force, like, 1 times 1, 2 times 1, 3 times 1, depending on where they are in their understanding of their facts. But again, now we can look at some patterning possibly with multiplication. It's not so prevalent as it is with addition and subtraction, but we'll talk about some things with multiples in a moment. Again, I could do some conditional formatting if I wanted to put some color on it, but the bigger piece here is, again, once students are maybe struggling with a few facts, it's really overwhelming to them to say that, oh my gosh, I don't know my multiplication facts. And then you can ask a kid, well, do you know your ones table? Yeah, I know my ones table. It's ones times whatever is what it is. So then you say, okay, take a marker, kid. You could print something like this out, or you could use it digitally and just put a mark through it or delete it if it's a spreadsheet. All right, do you know your 2 times tables? Heck yeah, I can count by 2s. I got that down. All right, well, let's get rid of that. Use a marker and get rid of that too as well. How about your 3s? Most kids are pretty good with 3s because of skip counting, things like that. They get their 3s down pretty quickly. There might be a few in here that they don't really know exactly, but again, they can just put a marker. And physically doing that really helps kids think about, hey, these are the facts I need to hone in on. The 4s, since I know my 2s, a lot of students pick up their 4s pretty quickly. Their 5s are easy because of skip counting, and it's just 5, 0, 5, 0 is pretty easy for students to pick those up generally. Again, it might be unique where a student isn't picking that up, so you would leave that fact for them or they would exit out. Generally, if kids know their 3s, or there's all different methods for learning 9s, with your fingers and things like that too as well. So we can get rid of those. Obviously, the 10s kids pick up pretty quickly. And 11s, generally, they don't have a big trouble with. Maybe they have trouble with these 11 times 12 and 11 times 11, possibly. But generally, up to 99, they generally don't have any trouble with the 11. So again, they can X those pieces out too as well. I don't know who said we had to go up to 12 times 12. I don't know why we didn't just stop at 10 times 10. Anyway, what this has done now is all of a sudden the students say like, these are the ones that I mix up all the time. And everybody has trouble with those too as well. And again, it could be some other facts, but physically having them cross them out helps have a little experience with what they know, what they don't know, and they can really focus in on. Multiplication facts is very similar. The one tip here, and I should have done this, I forgot to undo this, but there's a formatting piece inside of Google presentation. So when you do the division, it'll probably give you in a decimal form, which isn't bad. Again, kids should be familiar with decimals and versus fractions. But now I can actually use Google to say, hey, Google Sheets, hey, I want to actually use a fractional format. I have it here because I've used it before, but it's actually underneath more formats. And I can go to custom number format. And here it is right here. Here's the fractional format. I hit apply. And now everything's in a fraction. Again, we can have some conversations about, hey, why are these all ones? Why are these all whole numbers? Where are the whole numbers? What do you notice about the whole numbers? And that type of stuff. What do you notice about half fractions that are halves or fourths? Again, playing with the numbers. This last tab on here is just looking at the multiples piece. So if you type in 4 over here, it shows you all the 4 multiples up to 100. If you put a 3 in here or a 2 in here, again, showing kids patterns with numbers is a big deal for them to develop that number sense. If you want to really check out this number formatting, it's a little bit more advanced, I guess you could say, because it's using the modulus operator, which is just how many are left over. So it's just dividing and then saying if it's left over and there's nothing left over, then it turns green. There's a hundreds chart. Again, having kids build a 100 chart is a really good way with formulas too as well. You can check out the answers over here to see how I built them. You don't have to necessarily build it this way. Again, looking at the patterning. All right, so that's just the facts and talking about fluency of not only being quick and efficient and fast and accurate, but being flexible is really where we want our kids to be so that when they get into more abstract mathematics, they have those strategies to lean on. All right, the next one is dealing with more intermediate grades, probably moving into the third, probably more 5th grade if I were to do this, but you can obviously change it depending upon your students and not have them do all the formula pieces. There is some help with if statements if you're not sure exactly after I got done this with what the heck is an if statement, how do I use an if statement. But this is just the example that we came up with to create a calculator. So at the top here, here's a link out to support with if statements if you need more support. But basically, This first one is just a simple if statement. So over here, kids can enter in, whatever it might be. If you put in 12, it says try again. If I put in 9, it says correct. And basically, this is an if statement. It's basically saying, if this thing is true, put this. If this thing is false, this logical operation, if it's false, put this. And what it's saying is, does A2, the 4, plus C2, the 5, does it equal D2, the 9? If it does, go ahead and put correct there. If it doesn't, put try again. So that's just a simple format or the simple if statement, its format, and allows you to make some decisions and do things like saying something's correct or saying something is not correct or try again. So what we've done down below is kind of have a cool little calculator for kids to kind of leverage, and they can choose plus to add, and it comes up with 8. In this case, if we put a multiplication, comes 16. I can change this to a 5. So it's just a simple calculator. And over here, generally if I were using this with students, I would have this column hidden. So I'd right click on the column and hit hide column so that students wouldn't see what's over here. These are really just the answers, and you can see all it's doing is C9, the 5, plus C11, the 4, to give me a 9. The next one is just subtracting C9 from C11. This one's multiplying C9 times C11, and this one's dividing C9 by C11. So these are my answers. So what I'm going to do over here in the answer is do a nested if statement. So this is a little bit more complicated than a simple if statement, but it's basically an if statement within an if statement within an if statement within an if statement. So I'll kind of go through this with you, but I'm not expecting everyone to pick this up. So it's basically checking what operator is in C10. If C10 is a plus, go ahead and spit out G8. If it's not a plus, okay, that's false. So go to the false part of this if statement. And then there's another if statement in the false part. And it's saying, does C10 equal minus? No, it doesn't. It even tells me it's false. Okay, well then don't put C9, which would have been 1. Go to the false area. Does C10 equal X? If that's true, then go ahead and put out G10. And that's what it actually is doing in this case. And then it doesn't even get to check if it's division or not. I want to put in G11. So that's a nested if statement. Again, you can check that out on your spreadsheet if you'd like to learn a little bit. You can kind of try to rebuild it here. I would highly suggest just copying this drop-down menu. This is getting into data validation. It's actually using some emojis because the plus symbol actually means a formula. So if you're testing for the plus, it messes up your formula. So I just brought in emojis instead of actual text there too as well. All right, so that was more for your grades 3 to 5. We're moving into the middle grades here in an inquiry approach to help students understand what perfect squares are and square roots. A lot of students struggle with what the heck is a square root, but the idea is really just say, hey, if you have 16 things and you organize them in a square, it turns into be 4 by 4 square. So that's why the square root of 16 is 4. But if I have 17 things, it's not a perfect square because I can't put 17 things into a perfect square with whole numbers. So again, we'll just kind of dive right in here. I'm not going to go through every part of this particular activity. If you'd like to dive in more, you're more than welcome to. So I'm just going to give an overview. But basically, you have 4 tasks down below, or 5 tasks down below. And the first one's just, hey, multiply the numbers. So that's 1, that's 4, that's 9, that's 16. Obviously, we're building up to our perfect squares here, because most students are comfortable with their doubles when you're multiplying. Get that one wrong on purpose. And you notice with some conditional formatting, I changed to green or pink. So if I actually change this back to 64, bam, something appears. And what is happening, there's actually a row or a column over here that's off to the side. I can do that. Let's hide that. You can see I had a hidden column here that's actually checking. So it's actually checking, hey, does B8 equal 0? If it does, put a checkbox. If not, put a blank. And this one is saying if B9 equals 1, put a checkbox. And this one obviously would say if B10 equals 4, put a checkbox. So if I put a 5, you'll notice the check goes away, and so does that message. So when I put it back, the check comes back. And what this message does is another if statement. It's counting the number of checkboxes from M8 to what was that, M18. You can see it down here is a little count piece too as well. So it's counting 11. So that's what the if statement's saying. Do I count 11 check marks there? If so, go ahead and spit out all this text. Awesome job, blah, 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 watch the little link flow, blah, blah, blah. So it gives a little bit of instructions when they get everything right. And what the students are going to do is go out and watch a video about learning how to multiply values in a spreadsheet. And there's kind of like a little Easter egg in the video at the end. It tells them to put a certain value in here to make sure that they watch the video, because something else will pop up if they get the correct. So I don't know what it is. I forget. It's like 21 times 13. And they actually have to just build that expression. And if they do it correctly according to the video, something else will pop up. I don't think I have the right numbers, obviously. And then they complete task 1. They move on to task 2. It's kind of the opposite. Now they're saying, okay, when you take the square, when you square a number, what does that actually mean? Not what does it evaluate to? So again, as they move through this, then they get another video to watch to learn about how to, I don't know, I think it's exponents, not really sure. Let's see. I'm actually using the X on the keyboard for this to show multiplication. Oh, calculating exponents in a spreadsheet. So they learn about exponents and spreadsheets. And again, if they get it correct, something else will pop up. Task 3 gets them into, okay, now we're moving more into dealing with square roots. Okay, what is 3 squared equals 9? What does that mean? So if I take 9 things and I put them in a square, it turns into be a 3 by 3 square. If I put X's that don't work, it doesn't color code them oranges. They're orange. And I continue on. If I do that all correctly, again, something else will pop up. Task 4, it's now getting into the idea of what a square root is, a perfect square at least. Again, same idea. That's wrong. And then again, something else will pop up. And the final task is okay, now we have square root of 50. Go ahead and put that in a square, kids. And hopefully they start to realize that, hey, I have 38 X's remaining. Must be missing a row down below. I have 9 left. Yep, was missing a row. So if I put in x, I still have 1x remaining. And up top it says there's a problem. We can't create a perfect square. We still have 1 less x. So that's the whole idea of what does it mean to have a perfect square. And that gets into estimating. So if you have the square root of 52, then you know it's between the square root of 49 and square root of a 64. So it's like, 7 point something. And kids generally are not so good at estimating square roots because they think about dividing or cutting things in half rather than putting them in a square. All right, so that was activity 4. The last, that should be activity 5. Anyway, this one is our last activity, and then I'll share some other resources where you can find a lot of these type of ideas out on the web. So the graphing exercise we're going to get into with using a rope. So what I have here is an actual rope because we want kids to get hands-on, get concrete examples. What I'm going to do then is measure this rope. So we're going to start tying some knots in this rope. But first thing is we have 0 knots. So I want to know what the rope length is when there are no knots. And it's a little longer than a yardstick. So let me pinch that. It's about 38 inches, looks like. And then basically what it says is, okay, now let's tie 2 knots. And the kids take the rope and they tie it. And then a lot of times kids just tie another rope or knot right on top of that, which obviously uses up more rope because it has to go around another knot. And that's a great problem to have. It's a great conversational piece that, hey, what if someone does tie a knot on top of a knot versus what if someone just takes an end of a rope and ties a knot next to the knot, not over top of it. I'm going to try to keep these close together because I got to keep adding knots and I don't want them to be on top of each other. But again, if it turns a little messy, that's good. That's where the learning happens. That's where light bulbs go off. That's where your kids who are high flyers are like, whoa, I never even thought of that piece. So I tied 2 knots next to each other. Now I'm going to measure it with my yardstick. It looks to be about 32 inches. All right, now I got to tie 4 knots. So you see now I have 4 knots there tied, and the length of the rope now looks to be about 25. I don't have to be perfect here. And now I'm going to do 6 knots. So now you can see that I have 6 knots here. 1, 2, 3, 4, 5, 6. I measure that. It looks like about 18. And now 8 knots. I'm running out of, I didn't tie these too great. So here's one that I did earlier with 8 knots on it. And whatever, maybe it's 12, it looks like. So now I have my data, and again, getting that hands-on piece now where students are using real manipulatives rather than just all abstract pieces. What we're going to have kids always do is do estimating or predicting before calculating, sketching before graphing, having them do an estimation a lot gets them better at thinking, hey, does that answer make sense? Kids aren't good at estimating, so we have to help them estimate. So is this going to be a positive or negative? So kids, if they pick positive, they ask you sure. If you pick negative, they are correct. Hopefully you realize as the knots increased, the rope length decreased it. But this is really where sheets really help students build their mathematical algebraic thinking. So now I can say, oh yeah, I know slope is y sub 1 minus y sub 2. So I can actually use this and say, hey, I'm going to actually take equals my B4. I'm going to put parentheses because I'm going to divide it. B4 minus B3. That's my y change, and divide it by my x change. So I'm going to take my A4 minus my A3. So that I calculated the slope there. It automatically says, do I want to autofill? Sure. I just want to check to make sure it's doing it correctly, and it is taking the correct points there. And you can notice that my slope is sort of maintaining a constant. It's not exactly right, and that's where we can talk about, well, maybe I tied this knot a lot tighter than this one. It's a little looser, and we didn't use as much rope in this particular knot. So again, that's good to talk about, and why things aren't always perfect. And then basically completing the sentence below, as the knots increase, the rope got shorter. Tells you you're correct. And this is an inverse relationship, and that's correct too as well. So that's just a quick algebra activity. Also realize that students' phones on an iOS device has a Measure iOS that actually physically uses the camera to physically measure things in our world. And Google has a Measure Android app. I believe they just can discontinue this. Not positive on that, but I do know there's other measuring apps in the Play Store for your Android device that leverages the camera. It's pretty wild. They're really accurate. I was blown away when I used it before. All right, this is where really you get to explore. One of the greatest sites I've ever ran across for leveraging spreadsheet is called What If Math. They do have a tour. I'll show you that in a moment. But they also have a website that has a lab gallery I took to. If you click here, it'll take you back to the main page, but I linked you directly to the labs. And basically what this is the type of things that we've been doing, but they have lots and lots of spreadsheet labs where you basically are turning math into a laboratory science, where kids are investigating, leveraging spreadsheets. It's an awesome place. I wish I knew this existed or existed when I taught math a few years back. But they also have a tour just to kind of give you an overview of all the different types of labs they have that you kind of play around with yourself too as well. So that's a really awesome website. And then finally, if you'd like to make a copy of these slides, just click here. It'll automatically give you a copy of these slides to add to your drive. And then finally, I just have a whole bunch of elementary, middle school, and high school examples, as well as some professional development if you need to learn more about Google Sheets. Here's actually Google's official teacher center for learning about Google Sheets. A great place to start, but all these are really good places too. If you are a sheet master, this course is a free 30-day course. You can take any, or 30-day challenge. It's just basically 30 challenges to learn about, complex if statement accounting, VLOOKUPs, all different types of stuff. Really good website. Our website, SC Math, is linked there too as well. And finally, just realizing that spreadsheet is a tool for understanding and communicating mathematically to the masses. That's the whole reason we use spreadsheets in businesses, because it makes data understandable by the masses. So having students with those skills leaving high school is invaluable to them too as well. If you'd like to dive in a little bit more about that thinking, here's just a article online that talks about, really spreadsheet is an application of mathematics, and our students should be exposed to leveraging spreadsheets because it's a valuable skill. All right, so hopefully that was helpful for you, and feel free to reach out at any time. You can look me up on Twitter. There's also my email address there. So have a great day, and thank you for hanging out.